Hey everybody, this is your video for the Calculus Review 1.1 to 1.2, and our first is find the domain and range of the function. So the function is the square root of x squared minus 6. So we would graph that. Square root x squared minus 6. 6x. Sorry. Okay, so it looks like that. So that point is 0, and if I plug a 0 in, I can see it be 0. And this one, 1, 2, 3, 4, 5, 6. Looks like it'd be 6. So it appears to be anything to the left of 0 and anything to the right of 6. Let's check that out in the table. Control T. So at 0, it had a value of 0. Then it was undefined in between, and at 6 it had a value. So that domain is negative infinity, comma, 0, bracket, union, bracket, 6, comma, infinity. So remember, whenever you use negative infinity or positive infinity, it has to be with parentheses. And in this case, we needed brackets because it included that number. Okay, so now for the range, on the graph, it doesn't look like anything could be negative. But again, if we go back to 0, it was 0. So basically, we need from 0 up to infinity. So we have bracket 0, comma, infinity. Alright, so that's number 4, which is the first one. Now number 6, find the domain and range of this function. So this would be one where you could set your denominator equal to 0 to find the vertical asymptotes. So I'm going to say x squared minus 25 equals 0, and say plus and minus 5. So this would be this. Okay, let's go to a graph. Eight over parentheses x squared minus 25. Okay, so it's to the left of 5, it's in between negative 5 and 5, and it's to the right of 5. So negative infinity, negative 5, union, negative 5, 5, union, 5, comma, infinity. And of course, remember, since these were vertical asymptotes, this is where it's undefined. So that's why we had to use parentheses, not brackets. The next part is about the range. And so I need to know what this maximum is. Menu, analyze graph, maximum. Between there and there. Negative 0.32. And when I approximate that to a fraction, it's negative 8/25. Okay, so that was our maximum. And so on that, we go from negative infinity to negative 8/25 union 0 infinity. So on this part, we go back to it. It had a maximum right there. I used my y value to get that maximum. And then this had a horizontal asymptote at 0, at the y equals 0. Okay, our next one says find the natural domain and graph the function. So if I try to take a shortcut on this, I just plug a 3 in, and so if you do negative 3 plus 3, that'd be 0. The square root of 0 is 0. Okay, so let's graph it. Square root negative x plus 3. Okay, so it's opening to the left. The reason is because that negative sign at that particular spot flips it across the y-axis. If it were outside, it would flip across the x-axis, but this is inside, so it flipped the y-axis. And then it went to the side. Alright, so this would be from 3 that way, so from negative infinity to 3. Negative infinity, 3 bracket. And so that's the B graph. Alright, our next one. This is a piecewise function, and you just need to graph it. So to graph piecewise, remember we go to this button to the right of the 9, and we need a 2 by 2, so that's that one. And here I put 144 minus x squared.
You recording?
Yeah, I was.
I just want to show you that I did that Google Forms thing last night.
I saw it.
All right.
Yeah. Okay, so this is 144 minus x squared, and this is x squared plus 2x. Then our intervals are x less than or equal to 8 and x greater than 8. Okay, so now I want to do zoom fit. Menu, window, A for fit. Okay, so it looks like that. And so this we know is 8 because that's where it changes. So to the left of 8, it was the parabola with the 144 as the max, and then the other side was linear. Well, it appears linear right now, may not stay linear. Okay, so that would be the B graph, because it goes like that and then like that. Alright, our next one, we have negative 2 square root of the absolute value of x plus 3. It's a little unusual to have an absolute value under a square root. but I guess that just protects you to not have any negative or imaginary values. Negative 2 in front, square root, absolute value, x, and then outside of this, plus 3. Okay, so it looks like that. That's 0, 3, which would make sense because if you plug in a 0, you get 0 here plus 3. So that'd be the C graph. What kind of symmetry does it have? It's across the y-axis. And it's increasing from here to here. And it's decreasing from 0 to infinity. Remember, whenever we're talking about increasing or decreasing, we use parentheses, not brackets. So that'd be this one. Okay, so now we have that part. That was like number 41. This says determine algebraically whether it's even, odd, or neither. So I know based on the exponent that it's not odd. It could be maybe even. So we check through the graph. It's the easiest way. Negative 4x squared minus 7. Menu, window, A. Okay, so that's symmetric to the y-axis. So I graphed, and it's symmetric to the y-axis. Which means it's even. So up here, the reason why I knew it's not odd and maybe even is because of the even exponent. And then I just used the graph to determine the rest of it. The other way to do it, which is algebraically, is if you do f of negative x, and if we have negative 4 negative x squared minus 7, you get negative 4x squared minus 7. It's the same as the original, so it's even. So in other words, f of negative x equal f of x is even. So if you had this and got negative f of x, that means odd. So in our case, we got the same as the original, and so that was even. The easiest way is to just graph it, but you can plug in a negative x. Alright, and then on this one we have 3x over 3x squared plus 2. X over 3x squared plus 2. And so that looks like that. That's in diagonal quadrants, so to speak. It's symmetric to the origin, so that'd be odd. symmetric to the origin, so it's odd. And if you want to plug in, like we did before, f of negative x, or h, but h and f doesn't really matter. F of negative x would be 3 times negative x over 3 times negative x squared plus 2, negative 3x over 3x squared plus 2. And so this is basically negative f of x, which is odd. So if you get the original function except for a negative sign in front, that would be odd. Okay, now we're moving on to section 1-2 problems. Find the domain of f and the range and so forth. So this is a square root function that goes over to the side. So this would be negative 7 infinity. So basically, square root x plus 7, it's like that. And so it includes the negative 7 because that answer would have been 0. Now for the range, it would be from 0 up. So that's 0 comma infinity. For g, we have that one. So I'm just going to do minus 6. So that's this way, and so that'd be 6 comma infinity. And again, 0 comma infinity. Okay, so now for the domain of f plus g, got the square root x plus 7 plus that function. So it's basically just a little bit higher. 1, 2, 3, 4, 5, 6. Let's look in our table. So it's an error until 6. And see, at that point, it has 6 comma 3.6055, etc. So for the domain, we know it's going to be bracket 6 infinity. The range, you're not allowed to use that number, and so we have to figure out what it was. So we basically do the square root 6 plus 7 plus the square root 6 minus 6. So that's the square root of 13 plus 0. So we get square root of 13. So it's square root of 13 infinity. And then just to double check, remember you can do Control C to copy that if you'd like, and Control V to paste it. And I do square root of 13 as a decimal, and I got the same thing. On the next one we have times, and so we're basically doing square root x plus 7 times square root of x minus 6. Square root x plus 7 times square root x minus 6. Okay, so it looks like it's 6 again. Okay, sure enough. So it's 6 comma infinity. And 0 comma infinity, because it included 6 0. Okay, so then our next one has f of x equal x plus 5, g of x is negative 3x, h of x is 5 minus x. And we want f of g of h. So for this one, we are doing f of g of x, f of g of h of x. And so the first thing is we got to plug in h of x for x. So this going into the g function. So we do g of 5 minus x. The g function is negative 3 times x, so that's negative 3 times 5 minus x. Then from there you want to distribute, so you get negative 15 plus 3x. Now that we have that answer, we need to do f of that function. So the f function is x plus 5, so we have that plus 5, which gives you negative 10 plus 3x. Okay. On the next one, we're trying to do the 4th root of x minus 5. We have x minus 5, the 4th root of x, so we're actually going to use those two. We have x cubed and we have 2x. So on this one, it's going to be f on the outside, and so that's f circle g, because this is the f function, and then we plugged in the g into x, so that's like f of g of x. On b, we have 2 4th root of x, so we really need to start with 2 blank, which is really j, and then we plug in the 4th root there, which is g. So we do j circle g. So basically j of g of x. Our next one is x to the 1/16th. And so looks like if we do g twice, then that would work. So g of x is the 4th root of x, which is the same as x to the 1/4. Basically the 1 comes from right there. You make your root your denominator. So that's 1/4. And so we basically want 1/4 times 1/4. And so that'd be x to the 1/16th. And so that's j circle j. Remember, it had to be a power to a power in order to multiply. The next one has 4x, and so we're going to use the 2x function. So that's 2 blank, and so that's j. And then here we plug in 2x, which is also j. So basically 2 times 2x gives you 4x, and so that's j circle j. Okay, now on this one, these are the ones where it starts with having 3 functions. So on this one, we start writing our 4th root function, and so that'd be g. And then we have something cubed, and so that's h. Fourth root of something cubed. And then we plug in the x minus 5, which is f. So you basically start doing g, then h, then f, and so that'd be a. In the same way, this says 2x minus 10, which is not one of our functions, and so we need to think of that as 2 times x minus 5 and work backwards. So to start with, what we do is we go with the something cubed, which is h. And then from there, we need to do 2x cubed. So that's j. And then in place of this x, we need to put x minus 5, which is the f. All right, that's as far as we're going to be able to get today. I hope that helps.